Recording is rolling. It is Friday, September 2nd. We got ourselves a short day and a 3-day weekend coming up. So you guys just turned in your college questions. And you guys know that the when I see you guys on Tuesday, I'm going to pick up the linear motion take-home quiz, which is that half page I gave you guys yesterday. And also we're going to go over AP Classroom Unit 1 progress check. Let's go for a while. But today, I want to open up a projectile motion. So that's what we're going with today, projectiles. Right, so this is still kinematic motion. There's no new formulas. It's same formulas, same question. We're just the same green poster up there. These guys, these three amigos. But we're just looking in 2 dimensions. That's it. Now, if we're going into 2 dimensions, like this would be a projectile, right? So projectile, it's still in free fall. There's only one force on it, its own weight. But guys, which way does gravity pull? What's the only way gravity pulls? Down. Yeah, down, vertically. Okay. So do you think that say this cannonball is blasted, do you think that if the cannonball is going slow or fast horizontally, that has anything at all to do with this vertical motion? It does not. So for example, suppose I blast out this cannonball here, and at the exact same time, I just nudged another, let's say there's another cannonball to sit in a rest right at the corner and do a little tap. Right. Which cannonball is going to hit the ground first? Yeah, they tie. Yeah, they tie, right? Or what else was I going to say? I think you guys get that idea, right? Oh, how about this? So going from here to here, you can analyze the motion of the cannonball either vertically, like how far it's fallen, something did that, or horizontally, like how far across the field it's moved. Okay. Now, vertically, you guys know there's acceleration involved. In fact, what is the value of that acceleration? Yeah, 9.8 or 10 meters per second squared. Right? So pick your favorite. If it's an FRQ, AP will probably have both rigged up, and the answers are really similar. Okay? But guys, horizontally, suppose you're up here in a blimp and you're watching this cannonball go across the field. So you're basically seeing what it's doing just horizontally, right? Just picking up on its horizontal motion. Does that cannonball speed up or slow down going left to right? Or does it go constant velocity? It's constant velocity, isn't it? Because there's nothing pulling it left or right. I mean, you guys know we're ignoring air drag. We're ignoring air resistance. So if there's no air resistance, yeah, it's go constant speed, horizontally anyway, all the way across the field. Okay. All right, so questions about this. Let's pick this apart and solve this thing. Suppose I got a cliff that's this tall, 45 meters, and then blast this cannonball, and it lands 120 meters from the base of the cliff. Okay. There's enough information there that you can figure out how fast the cannonball is going to blast from the cannon. Okay. But before I just walk you guys through it, or maybe I'll have you guys tell me how you think this should be solved. So what do you think is we should start with to figure out the blast speed? Should we start with horizontal information or vertical information? What do you think?
Vertical.
Yeah, I like vertical. And the reason I like vertical, because horizontal is actually getting pretty close to answer. Like horizontal is going to be the last step, because you know it goes this far in some amount of time. And if you could answer that question this far in so much time, that would be the answer, wouldn't it? Right? Just divide those two, and then you would get blast speed, because that would be the horizontal speed. That's the horizontal component of velocity. It's how fast it's going across. Okay? If only you had the time, and you're right, you do get the time from the vertical information, because the taller the cliff, the more time it's in the air for, right? Okay. So I guess that's a good first question is, well, how much time is that ball in the air for? And who knows the answer to that question? How about this? How much time does it take to fall 45 meters starting from rest?
3 seconds.
3 seconds. You guys remember this? Remember this table from your notes? Right, not too long ago, right? I mean, it's still the same vertical motion, right? Remember, if you just roll a cannonball off the edge, has the exact same vertical motion, right? They hit the ground at the same time, right? So yeah, to fall 45 meters, that's going to take 3 seconds, right? And if you didn't quite memorize it off the table, then couldn't you just use the shortened version of that first kinematic equation? Say height change is equal to 1/2 gt squared. Right, that's a simplified version of that first kinematic equation. Right now, it's okay to use this as long as no, V initial would be 0, right? But that's true in the vertical direction. That's not true in the horizontal. Okay. That's one thing that students mix up with projectiles. It's like, horizontal, vertical. You guys know horizontal is going across and vertical is going down. So anything to do with a height change, we only care about the vertical, right? Like if I go to the previous step and expand it a little bit, it would look like this. V naught in the y direction times t plus 1/2 gt squared, right? The V naught in the y direction is just 0 because this cannonball is blasted horizontally. So leaving the cannon barrel, see how it's not moving up or down? You guys see it? Okay. Okay. So it just boils back down to this. Okay. And then you're solving for t, knowing h is 45 meters. 45 meters equals 1/2, got 10 meters per second squared, t squared. Okay. Half 10 is 5, divide it down. 45 over 5, that's 9, square root of 9, 3. So t equals 3 seconds, just like you guys just told me. Skip a few algebra steps there. Okay. You guys can do algebra, right? You guys good? Okay, so now we know the time that this cannonball is in the air. It takes 3 seconds to get from here to here. Hey, if it takes 3 seconds to get from here to here, is that true vertically and also horizontally? Right? It's 3 seconds either way, isn't it? Right? It takes 3 seconds to fall, takes 3 seconds to cross. Point A to point B takes 3 seconds, right? Yeah, all right. You guys see that? Okay. So if it goes 120 meters in 3 seconds, how fast is it going across the field?
40 meters per second.
40 meters per second. All right, so now we're going to switch over to horizontal because this was all vertical, wasn't it? We just did some vertical analysis and got the time. Now we're going to switch over to horizontal analysis. We're going to say how far it goes is equal to how fast across times time. Okay. Now this projectiles, I'm sorry, you guys see I'm putting some subscripts on my variables that are indicating direction. Okay. Because remember, all these variables are vector quantities, except for which one on this page is a scalar? Time. Yeah, time is the only scalar, right? Which means it has a magnitude, right? But no spatial direction. But all these other variables, except for time, are vector values. They have a direction. So I care about what's going on vertical, what's going on horizontal. Okay. Well, I know that horizontally there's no acceleration. Gravity doesn't pull horizontally, right? And we're ignoring air drag. So the only equation, well, there's only one, and it's this bit right here, x equals vt, right? Is that the only thing that's ever going to apply horizontally? Okay. Right, so pop in 3 seconds, and I'm solving for this, and I know it went 120 meters because, well, that was part of the setup, the given. Divide down 3 seconds. You guys see the horizontal velocity is going to be 40 meters per second. Okay. And since the cannon was blasted horizontally, that's also the blast speed from the cannon, isn't it? Okay. You see it? Okay, so that's how fast that cannon's blasting that cannonball. Okay. Questions so far? Is that it? All right, how about this? I wonder how fast this cannonball's hitting the ground out here, how fast it's crashing. Okay. Now, if it was blasted at 40 meters per second, which we just figured out, okay, do you think it's picking up speed as it's falling? Faster, faster, faster? Kind of makes sense. I wonder what speed it builds up to. Can you guys think of a way you might approach and solve that? It is like crash landing on an angle, isn't it? Huh. Do you suppose you could take this crash and break it into components? Okay, let me do that. I'm going to take this. I'm going to blow this picture up. Blow it up right here. So like, here's the ground. Here's this thing. Let's see how I want to do this. You want to do it this way. Crash landing like this. There's a cannonball crash. I'll call it V-crash. Okay. So now that's a vector because velocity vectors are, well, they're vectors, right? Okay. They have magnitude and direction. So I'm going to split that into components. So the cannonball is going across the field, but it's also coming down at the same time. Right? And if you looked at its actual projectile path, this projectile path is coming out like this. See how the final velocity is going to be flush to this path right here, that curve. Okay. So I bet this would be like a parabola type motion, wouldn't it? Okay. But all we care about is that moment that it's crashing into the ground, obliterating that anthill. So what's this component right here? You guys already know. What is this? 40 meters per second. And isn't this v sub x equals 40 meters per second, because isn't that what we just did on this side? We got the velocity of the cannon, therefore the horizontal component of velocity going across, right? So you know that, huh? How could you figure out how fast it's picked up to vertically? Yep.
Final velocity equals initial velocity plus acceleration times time.
Boom, boom, right? Now, since this is all vertical, let's go piece by piece. What is the initial vertical velocity?
0.
0. Because remember, leaving the cannon, it was going really fast. Why is it 0?
It doesn't have any vertical
direction. Right, no vertical component, right? The cannon blast was entirely horizontal. The cannon blast was not at all vertical. That's why this is 0. It's 0 vertically, right? Right, so this is 0. Right. This number is about 10, let's call it, meters per second squared. For how many seconds?
3.
3. You guys figured that out. You guys remember you told me, well, to fall 45 meters, that would have taken 3 seconds, right? So that means it's been speeding up vertically for 3 seconds, right? Right. So that's it. Let's do the speed it picks up to in the final and the y direction equals v naught y direction plus gt. Maybe I'll call down positive. So it's only ever going to right and down, right? So down is positive for this guy. Must be 0 meters per second. Doesn't matter how fast the cannon was blasting, it was horizontal. 10 meters per second squared is picking up, does that for 3 seconds. That's that number right there, right? Okay, so that goes right here. The final in the y direction is equal to 30 meters per second. Is that okay? Okay. So just to recap, going across the field, that's 40 meters per second. That was true from the moment it left the cannon barrel all the way until it was about to crash land. That never changed. It's not accelerating horizontally. Vertically, it was picking up speed. Well, if it had 3 seconds to follow, it would have picked up to 30 meters per second. You guys remember that from the last couple weeks of class. Okay. Put it all together. Who knows? Who can see is what the crash speed is going to be?
50 meters per second.
50 meters. There you go, 50 meters per second. You're saying the Pythagorean theorem, which is the generalized version of that. You're right. You guys see a squared plus b squared is c squared. Is that okay? Can you use Pythagorean theorem with velocity values? Yeah, sure. Yeah, and you guys see this is a 3, 4, 5 right triangle. 3, 4, 5 right triangle. So you run the Pythagorean theorem. Okay, so this is square root of 40 squared plus 30 squared. I slipped the units in here too, but kind of meters per second. 50 meters per second. There you go. Right. So the velocity of the cannon was 40 meters per second. It's been picking up speed vertically. Pythagorean theorem, boom, 50 meters per second is the crash speed. Crash speed. Speed is the magnitude of velocity, right? Okay, so you know what? Does anybody remember what angle this is? Let's say this angle right here. You guys remember how to get that angle theta? Yeah.
Inverse tan of 40 over 30.
Boom. Inverse tan, 40 over 30. That looks like 53 degrees. 53 degrees, and that would make this 37 degrees. Hey, do you always see 37 degrees and 53 degrees for a 3, 4, 5 right triangle? Yeah, it should look familiar, right? All right. Questions on that one? Okay. So I do have another projectile lined up. Let me give you guys like a big picture framework for solving projectiles. Okay. It's you know, if you guys want to see the resources that was going to give you guys, they've been posted on Google Classroom for a few weeks now, so you can look ahead if you want to. Okay. But you guys remember how this last week we've been juggling the 5 variables: time, acceleration, displacement, initial velocity, and final velocity. I said, well, if you make that little taxi V checklist, as long as you can identify 3 variables, it is solvable. Okay, remember that? Okay. And sometimes there's something that's a little bit hidden or implied, like and so some of you guys were asking me recently. One of the college physics problems said like a ball is hit to maximum height, and you couldn't solve it unless you realized that at maximum height. What do you know about one of these variables at maximum height?
Final velocity.
Final velocity 0, right? That would indicate maximum height, wouldn't it? Because at maximum height, final velocity goes to 0, right? Okay, but now we've got projectiles, so we're dealing with 2 dimensions. And interestingly, the horizontal component doesn't accelerate, so isn't it just some version of distance, speed, and time? Right, so we have like this two-part table, right? We've got vertical information, and we got horizontal information. Okay, and okay, so this x and this x are totally different ideas, right? So I'm going to change this x to a y, to like the vertical displacement. Okay. Okay. Now, if we're talking about projectiles, oh yeah, thank you. Isn't the acceleration always pretty much always going to be provided by gravity? So maybe like 90, 95, 99% of the time, it's actually going to be g, right? Or you could just say acceleration in the y direction, which, right? I'm going to add to these subscripts. This is v naught in the y direction and vf in the y direction. Okay, and then over here, maybe x could just represent horizontal displacement, so x compared to y. Okay, sometimes y I'll call h for height, okay. Height change. Okay. And then this v, I'm going to do v sub x. Okay. And since we just walked through a projectile example, you guys know that v sub x is going to stay constant, right? As long as there's no acceleration, and well, it's kind of implied by these three variables here, right? Okay. So remember, anything dealing with this vertical information or anything that's accelerating, you guys hit these three full kinematic equations. But anything that is not accelerating, there's only one equation, and it's this one right here: distance equals speed times time. Okay, say displacement equals velocity times time. Right. Okay. Now, comparing here and here, let's look at a roadmap of what we just did to solve this exact problem. Because the original question was, what's the velocity of the cannon? Okay. So you guys are trying to solve for this, the velocity of the cannon, right? And so I'm trying to give you guys a forest for the trees view, right? So we're up here in a blimp, we're looking down on the forest, we see all these physics variables. What did we have and what were we trying to solve for, and what was the roadmap through the forest, right? Guess what we're doing. Right, so see, I did give you the height of the cliff, like the vertical change. I gave you how far from the base landed. So you had this, check, there's the height of the cliff. I gave you guys where it landed, check, you had that. Okay. What else did you have on this checklist? Gravity. You say, okay, well, this would be about 10 meters per second squared. Right? There's a strong implication that you're on Earth. See, like if you switch planets to Mars, would you get a different answer? Yeah, the answer would be different. So, okay, I mean, you'd have to sort of know that to be able to solve the problem, right? Unless you're like solving in terms of variables. You have a general solution. That'd be fun too. And there, do you think there's one more thing that you guys know? Ah, exactly. Initial y velocity. All right. Because what was this number? 0. Because the cannon was aimed exactly horizontally, so this had to be 0. That means, oh, just put a check to say that you knew the information. You guys do a real general view, right? Hey, remember I told you guys if you know 3 of these variables, it is solvable. Okay. What about just the plain x equals vt? How many things would you have to know to solve it? 2, right? If you know 2 things, you can solve for the third, right? So let's see. From the vertical information to the horizontal information, or back and forth, do you guys see that there's only one value that is the same? Time, which is the scalar value, right? You guys see that? Because all these other values are vectors. Gravity, that's only vertical. Height, that's only vertical. These guys are only vertical, little subscript y. Horizontal displacement, that's only horizontal. Horizontal component velocity, that's only horizontal. But time is the scalar. So time is like, I imagine this being like the bridge that bridges horizontal and vertical information for projectiles. Right? Like, see, if you solve it on one side of this table, can't you just transfer the time to the other side? It's the same time, no matter how you analyze the problem, right? And that's what we just did. We set up a kinematic equation from the vertical information because we had enough vertical information to solve some stuff, to solve for time. And take that time and transfer it over here, and then you can solve for v sub x, which was the velocity of the cannon. Okay? You guys get it? Questions so far? All right, let's take a look at this other warm question. What is the, oh, okay. So now we got this cannon down on the ground, and it's gonna blast the cannonball. Ooh, does that angle look familiar? I might be doing some tricky Griffin math here, but let's say not tricky. I'm trying to help you guys out, right? It's a very special angle. So I got some questions lined up. I wonder, what is the maximum height of the cannonball? I wonder what's the amount of time it's been in the air. And ooh, what's the range? That's to say horizontal displacement. I could maybe call that X. Like I wonder where the cannonball is going to land. Right? We got a big flat plane. Right, launch it up. Okay. So you guys see that these are all process questions. Yeah, we got about what, 6-7 minutes left. So all right, let's start up. Yeah, let's walk through this together then. All right. What do you think a good first step is to do to start analyzing this problem?
Do you have
Uh,
like either?
okay, yeah. You know what, why not? I guess we got we got this kind of framework. Let's see what we do have. So vertical information, horizontal information. I mean, that could be pretty good, right? So time, acceleration, go y, v naught y, vf y, and then x, v sub x, and t, something like that, right? So we got ourselves a framework. What do we know from this list already? Acceleration, yeah. We know this is, well, it's 10 meters per second squared downward, right? Now, if you say I'm blasted kind of upish and gravity's pulling down, so you guys know some number somewhere is going to have to be a negative. So we have to assign a direction. What do you guys feel like today? Up negative or down negative? Down negative? All right, so I'll call this negative 10 meters per second squared. Right? Anything else you might know?
The initial.
Okay, so here you guys say something about these velocities. Okay, so yeah, now it depends which question you're answering and how we're going with this. So you do know final velocity if you're answering strictly this first question. See, it says what's the maximum height of the cannonball? Because what is the final velocity y direction up here? That would be 0, right? Now, I do have some other questions where that's not the final location, like the range of horizontal displacement is actually over here, isn't it? Okay. You guys know with all these equations, there's some initial point, some final point, and subscript initial, subscript final. Okay, so we're either going from initial to final or initial to final, right? You could go either way. Okay. Now, if you go from this initial to this final, then you would know VFY is 0. So yeah, I'll go ahead and do that because that was the first question I asked. Give me a second. But if you go from this initial to this final, I guess we could say is you could know this. Whatever the initial velocity is strictly vertically, just the vertical component, it's same magnitude but opposite direction where it's landing. Right. You could also say from here to here, looking for range. What is the vertical displacement from the ground back to the ground? That would be 0, right? Okay. No, that's not 0 for the max height question, but it would be 0 for the range question, right? It's that. So I got to pick what's my initial point or my final point. Initial point is the cannon. Final point. Well, that depends what I'm asking. Is it here? Is it here? So let's look at this. Let's tackle this first. Okay. Do you know anything else at this point? I bet we're gonna have to do some trigonometry. Do you think that we should take see this blast speed 100 meters per second? Do you think that it's going kind of up and kind of to the right? Right? Could you quantify how much up and how much to the right? There's a reason we took a few days to do some trigonometry, right? How much up and how much to the right? See if you guys can beat me to the answer. How fast is it going strictly vertically? How fast strictly horizontally? Who figured it out? Yeah.
Vertically, you got 79.97 meters per second.
Ah, you know, you got it. And then horizontally is
Not there yet.
all right. Yeah, Brady got it 60 meters per second. All right, there we go. Hey, is that a 3, 4, 5 right triangle? How many guys know as soon as you saw 53 degrees, like, oh, that's gonna be 3, 4, 5 right triangle? Okay. Here, how could you get that? Isn't that 100 meters per second multiplied by sine of 53 degrees is equal to that? Okay, and this is 100 meters per second multiplied by cosine of 53 degrees. Then you get that. Okay, that's where it comes from, right? Okay. 100 cosine 53 degrees, 60 meters per second. Boom, right there. Okay. Okay, so now we know how fast the cannonball is going across the field. In fact, if you're up in a blimp, is it just going 60 meters per second across the field the entire time? Okay. And you also know how fast it's going strictly vertically leaving the cannon barrel. So if you're like down here on the ground and you're just getting the vertical component, it's going that fast strictly up, leaving the cannon barrel, right? 80 meters per second. Okay. Is that okay? Cannon blast at 100 meters per second, but it's only going vertical 80. Okay, because on an angle. Okay. In fact, that's the one we care about to find maximum height, isn't it? Okay. So let's go back to that checklist. 80 meters per second. This is positive 80 meters per second. Okay. Oh, hey, we've identified 3 kinematic values. That means you can solve for this. And if VFY is 0, that means this would refer to H max, wouldn't it? Right? Notice I haven't said anything about time, but we have a lot of other information, which means that what's the most direct way to solve this? First, second, or third? Third, yeah, that guy right there. Or that's the one that doesn't mention time. Okay. Yeah, let's totally do that. So I'll go VF in the Y direction squared equals V naught in the Y direction squared plus 2G H max. Okay. Where this is going to 0 to correspond to H max. This is 80 meters per second. And then G we're calling negative 10 meters per second squared so that we can get the signs to agree, right? Gravity's pulling down because it's blasting up. H max. Okay. Gonna cut through some algebra steps to save myself some time and paper. 80 squared divided by 20. Right, because subtract, divide by a negative number, the negatives cancel. I'm getting H max equals 320 meters. Okay, so that's how far up cannonball goes. Okay, is that okay? 320 meters. Okay, you guys good so far? All right, so ask a couple other questions. They've got just enough time here for what's the total time in the air? You know what? Since we got from here to here, I bet we could do the time from here to here and then just double the time. Think we do that? Okay, solve for this t. Okay, let's do that. So I think I could go VFY equals V naught Y minus GT. Okay, can I do that? Okay, so it's going to 0 meters per second from 80 meters per second strictly vertically, 10 meters per second squared times time. How much time does it take to get to the max point? 8 seconds. Okay, so it's 8 seconds on the rise. Hey, is it also going to take 8 seconds to fall back down? So what's T total? 16 seconds. Right. That's its hang time, I should say, right? The hang time is 16 seconds. Right. And we're about to put this all together. Because if you know the hang time is 16 seconds, and it's going across the field at 60 meters per second, can you put 2 and 2 together and figure out how far it goes? What we do today. Right here. So how far does it go? dxt 60 meters per second, 16 seconds. See what that is. 960 meters. Ba-boom. There you go. That's how far a cannonball goes. That's a horizontal component, right? That's the range. Okay. All right. You guys good for this week? Okay, so at least got you guys kickstarted on projectiles. You guys will finish the linear motion quiz by Tuesday and also the AP classroom. All right, and I will see you guys. You guys have a great Labor Day weekend.